Oh, this video is about circle theorem proofs, and you can see an example of an exam question on the screen. You might like to have a look at this and see what you think at the moment. We're then going to go through and look at how you can do proof questions, and we'll come back to this and you can have a go later on. Okay, so here's your first task. I've got two questions here for you. There's an easier one with numbers and a harder one with algebra. I would suggest you try both of these because what you do with the numbers is then the same method with the algebra. What we're trying to do is, first of all, find as many angles as you can, and then we're trying to show that the angle BAC, that's these two angles combined, is 90 degrees. So pause the video and have a go. I'll give you one hint though, which is to look out for isosceles triangles. Okay, here's the solution. With the numbers, we start off with 80 degrees here, and we've got an isosceles triangle because we've got a radius and a radius. So 180 take away 80 divided by 2 gives me 50 and 50. This angle's on a straight line, so that's 100. So 180 take away 100 gives me 80. Divide that by 2 and we get 40 and 40. So we've shown that this angle here is 90 degrees. Okay, so moving on to the algebra. We're going to do the same thing, but instead of 80, we've got x. So we're going to do 180 take away x divided by 2 to find these angles here. Now that simplifies to give me 90 minus a half x. Now this here will come up several times in the circle theorems proofs. So make sure you do understand that and where it's come from, because that will come up several times. It's because these angles are going to be the same. It's not an isosceles triangle. So with the numbers, it was 180 take away 80 divided by 2, which gave me 50. With x, it's 180 take away x divided by 2, and that's the simplified way of writing that. Okay, so 90 minus a half x. This angle here is on a straight line, so this is 180 minus x. When you put this into this equation here, you actually get 180 take away 180 minus x, because you want to figure out what's left over here. So you're actually just left with, you end up with x to split in half, so you get half x and half x. Okay, let's have a look at this angle here. What do you notice about this? Well, actually, if you add these two things together, half x plus 90 minus a half x, you're just left with 90. So we've shown that whatever angle x is, the angle in a semicircle is a right angle. Now that's not exactly how you'd write down the proof in an exam. If this was an exam, you'd need to write down a reason with each of your lines of working. So let's have a look at that now. You might like to pause the video and have a go at this. This is very similar to an actual exam question that came up a few years back. It basically said, prove that angle BAC is 90 degrees without using any circle theorems. And a lot of students struggled. So you might like to have a go, pause the video, and then I'll go through the solution. Okay, here's the solution. The first thing that most people didn't realise you had to do is draw in this line here from A to O. That's really important. And then you look out for radii. I can see 3 of them. These are all the same length. That creates isosceles triangles. I'm going to decide to call those angles that are the same x, and those ones y. And here's what I'd write down. I would label the diagram in the exam. Examiners do look at that, but I'd also write down what I've done here. These are the angles I called x, these are the angles I called y, and here's my reason. For a proof question, any proof question to do with geometry or angles in an exam, you need to write down your reason. So here's my reason. Okay, next up, I'm going to look at this big triangle here, in this one here, and I'm going to, well, what do I know about the angles in that triangle altogether? These angles here, these ones here. What do I know about them all? Angles in a triangle add up to 180. So that means, actually, add all those up, x plus y must be 180. Again, what's my reason for that before I go any further? Angles in a triangle add up to 180. And then I can go through and actually simplify this. It becomes 2x plus 2y is 180. Divide both sides by 2. And we've proved it. We've proved that x plus y in this diagram, i.e. angle BAC, is 90 degrees. Whatever angle x is, whatever angle y is, it will always be that BAC is 90 degrees. So we've proved the angle in a semicircle is a right angle. So just remember in the exam to make sure you put down a reason with each line of your proof. Okay, here's another task for you. I'd like you to have a go at, it's the same as before. There's numbers or there's algebra. I want you to find as many angles as you can. And we're trying to show that the angle at the centre, this angle here, is double the angle at the circumference. So these two here added together. So with the algebra, that's the angle here at O is going to be twice the angle here at A. Sorry, you can't really see it says A there. So this angle here. So pause the video and have a go. Okay, here's the solution. So first of all, it's looking at isosceles triangles again. So with this angle of 30 degrees, we've got these two sides the same. So the angle here and the angle here will be the same. 180 take away 30 divided by 2 gives me 75. Let's do the same thing with the 40 degrees. 180 take away 40 divided by 2 gives me 70 and 70. Now, angles around a point here add up to 360. So 360 take away 40 take away 30 gives me 290. What do we notice? Well, we've got 145 and 290. So we can see 290, the angle at the centre. 290 is twice the angle, 145, at the circumference. And we're going to do the same thing with the algebra. So to start off with angle x, 180 take away x divided by 2 gives me 90 minus a half x. I did say that was going to come up several times today. We do the same thing here with y, and we get 90 minus half y. Okay, angle at the centre here, these are all around a point, so 360 take away x, take away y. What do we notice about the angle at A and the angle at O? Well, the angle at A, if we add these together, gives me 180 take away half x, take away half y, and that is half of the angle at the centre. So we've shown that the angle at the centre is twice the angle at the circumference. Okay, so here is that exam question from earlier. And this was a specimen exam question. You can pause the video and have a go. Okay, so here's the solution. First step is to draw in the line AO. That's what a lot of students wouldn't realise that you need to do. And then to label these angles at X and Y. Okay, I know that this angle here is going to be 180 take away x divided by 2 because I've got an isosceles triangle here. For the same reason, I can get that this angle over here is 90 minus y over 2. The angle at the centre here, these angles are around a point, so 360 take away x, take away y. So here's what I'd write down in the exam. I'd explain what I'd done to calculate BAO and CAO, and I'd put my reason. Base angles of an isosceles triangle are equal. Next, I would explain how I calculated BOC, angles around a point add up to 360. Then I would do a calculation. I'd say this angle here, BAC, is equal to these two added together. Add those together and we get 180 take away x over 2, take away y over 2. Now if I double that, I'm going to get 360 take away x, take away y, which is, so double BAC is the angle at BOC. So we've proved that the angle at the centre is twice the angle at the circumference. That's the mark scheme for this question. I think well, there's a few methods you could do this. They've actually said that line AO, that's the one we drew in here at the start, they've talked about extending that to a point D. So there is actually an alternative method that you could use for this question, but the one I've shown you here would get full marks. Yeah, you're welcome to pause the video and have a look at the mark scheme if you want. Okay, now having proved the angle at the centre is twice the angle at the circumference, we can actually use that to show that in this diagram here, angle X and angle Y are the same. Now essentially that is another one of the circle theorems that we're proving. It's angles in the same segment are equal. So you might like to pause the video and have a go at that. and then I'll go through the solution. Okay, here's the solution. The first thing to do is to look at this shape in red and realise that if the angle at the edge, if we call that x, the angle at the centre is going to be 2x. We can do the same thing with the shape in blue. If the angle at the edge there is called y, the angle at the centre is 2y. So we've just shown that the angle at the centre could be called 2x or it could be called 2y. Divide both sides by 2 and we've shown that x equals y, i.e. angles in the same segment are equal. Okay, here is another task for you to have a go at. This one is it's basically proving that the length of a line or length of a tangent from a point to the circle and then the length of this line from the same point to the circle in a different place, those two lengths are going to be the same. And we can use Pythagoras' theorem to show that. You might like to pause the video and have a go. If not, I'll give you a hint in a moment to get you started. Okay, my hint is that you can call this length r, and then call this line here, the one they've got in common, call that one, we don't know what it is, we'll call it x. And then try using Pythagoras' theorem. Okay, here's the solution. So those two radii, we'll call those r, and the line length that they've got in common we'll call x. Now that means this length here, AC, is going to be x squared minus r squared. That comes from this calculation here. Pythagoras' theorem says that the square of the two shorter sides, that's the square of the hypotenuse. If we rearrange this to make AC the subject, we get this here. You can do the same thing for this triangle. It's exactly the same calculation, and we end up with exactly the same answer. And that proves that AC and CB are equal. Now, again, if this was in an exam, I would actually write down what I was doing to find this one as well. But it's exactly the same as the calculation here. Okay, so here are just some final things, reminders about things you can do with circle theorem proofs. My tips for you are these. Look for radii of circles and isosceles triangles where base angles will be the same. Remember that you can add lines to diagrams, and sometimes that is essential. And remember to use your algebra X for unknown angles and Y if you've got a second unknown angle. And then think about doing things in terms of X if you can, rather than introducing extra letters. Okay, thank you very much.